If you could turn to page 335 in the book, we're going to be talking about absolute value functions today. So first we need to discuss, what do we mean by absolute value? So when we are talking about absolute value, then we need to know what is the notation, first of all. So absolute value, we put bars around a number or a letter that stand for absolute value. These mean take the absolute value of something. And when it's asking us to take the absolute value of something, it's saying make it positive. Absolute value makes everything positive. So if I said take the absolute value of 1, well, that is positive already, so if I'm going to make it positive, I leave it 1. But if I'm going to take the absolute value of -1, then I have to change it because we want to make it positive. So absolute value always makes things positive every single time. So down below, they give us a picture of a general absolute value function. This is the parent graph for absolute value. It looks like a V shape. And when we graph this, it always starts in the center, where they've labeled vertex. So we start in the center, and then it has the same slope on each side. It's always going up 1 over 1, up 1 over 1, up 1 over 1. Same thing on the left, up 1 over 1, up 1 over 1. So just like the quadratic had a slope, the quadratic slope changed though. This one always goes up 1 over 1, but we do have to repeat it because it is symmetric. It does have that axis of symmetry down the middle. So the starting point is the vertex, just like they've labeled. That line going straight up and down is the axis of symmetry. It always starts with x equals, and then since this one goes through 0, it would be x equals 0 for the axis of symmetry. And the vertex would be the coordinate 0, 0. I'm going to move the x equals 0 so it's underneath the axis of symmetry box. So anytime we don't know the parent function, we make a table, but they did that for you. They said, okay, I'm going to pick my x values. They picked -3 all the way down to +3, and they plugged them into the absolute value function. So if we plugged in -3, we get +3. If we plug in -2, we get +2 here. So they plugged in all those values, made a table, and got this parent graph. And this parent graph is what we're going to base all of our graphs off of. Just like quadratics, we had a parent function, and then we had to decide on horizontal shifts, vertical shifts, if it's stretch, shrink, or neither. It's the same concept that we've been using with all of our graphing. And we're going to ignore this middle part. It's not going to help us as we do our graphing. So we know the parent graph was that V shape. It always had a slope of 1 over 1. And now we need to see what will the numbers around this basic function do. So our basic function was just the y equals absolute value of x. That was our parent graph. That's what our parent graph looks like. Or the equation for the parent graph looks like. So we need to know, well, what does this 2 outside our parent graph do to our function? So think back to quadratics. Quadratics had the y equals parenthesis, a should go in front of the parentheses, so y equals a parenthesis, x minus h squared plus k. So this +2 is in the same spot as the +k on the quadratic, and it's going to do the same thing. This will give us our vertical shift for our absolute value functions. So with absolute value functions, that's also k. Tells us our vertical shift. And just like quadratics, then this 2 will tell us to go up if we're positive, and down if we're negative. So we should draw in our coordinate system. So the parent graph normally starts here in the center at 0, 0. But because we have a vertical shift up 2, our vertical shift goes up 2, then we're going to actually take that point, counting from the center, and move up 1 spaces, 2 spaces. So that's our new vertex. That's our new starting point. We've moved that up 2, and now we do our slope. So notice we haven't talked about horizontal shift yet. That is coming, but we haven't talked about it yet. And we have to talk about our slope. So slope is normally just 1 over 1, repeated on both sides, because our function is symmetric. But it is possible to change the slope as well, which is also going to be shown later on. But for now we know it's up 1 over 1. So starting from our vertex, from the point that we moved up to, we go up 1 over 1, and up 1 left 1. Now, parabolas, the quadratics, were a U shape, but absolute value is a V shape. It just goes straight through those 2 points. I always remember absolute value, and the word V, or word value starts with V, so that's the shape of my absolute value function. So then we could also name the axis of symmetry of this. We split it up, but the axis of symmetry still goes through the center. So my axis of symmetry is the line x equals 0. We find that 0 from where it crosses the x-axis. And my vertex is the point that we started with. So my vertex is the point 0, 2. Okay, so that covers our vertical shift, but we know there's other possible shifts when we are graphing absolute value or when we're graphing pretty much any function. So the key concepts box shows all of the different possibilities. Shows it in kind of a mathy way, but it still shows it. Shows us that our vertical shift is up or down depending on the number behind. Our horizontal shift is determined by the inside number, if it's inside the absolute value bars. And when it says translation right, if it's negative, we actually go to the right. If it's positive, we go to the left, just like with quadratics. And then we also may have a vertical stretch, or they use the word compression, but really we're saying shrink. That's what we've been working with. So this number out front can tell us if we have a stretch, shrink, or neither. So stretch was when a is greater than 1. Shrink is if it was between 0 and 1. And neither if a equals 1 or negative 1. Then it's also possible to have a flip. Reflection is the same thing as a flip. Again, it's determined as by the negative out front. We've never talked about flipping across the y-axis, just the x-axis. So those are all the same things we did with quadratics. So now let's do an example with a couple together. What is the graph of the function y equals absolute value of x minus 2 plus 1? So we start by identifying the horizontal and vertical shift. We decide if it flips or not. We decide if it has a stretch, shrink, or neither. And then we're also going to put down the axis of symmetry equation and the vertex. So horizontal shift was the number found inside the parentheses. That -2 means go right 2. The negative goes in the opposite direction you expect when there's a horizontal shift. The outside number tells us to go up 1. The outside number here was our vertical shift. It's positive, so we go up 1. Our graph does not flip because in front there is no negative sign. So no, it doesn't flip. And then stretch, shrink, or neither, if there's nothing written here, we know there's an invisible 1 when it's in the front. So we know that it's neither. So now we can graph our picture before we determine the axis of symmetry and the vertex. So we draw our coordinate system, starting counting from the origin, from the center of the graph. We take this point. Horizontal shift says right 2, so we take this point and go right 2. Vertical shift says go up 1. So we go up 1. So now that is our vertex. So our vertex is the point 2, 1. Notice that's based off of our horizontal and vertical shift. The vertex and the horizontal and vertical shift are the same thing, just written in a different way. So from there we have to do our slope. Normally the slope's 1 over 1. If there is a number in front, that can change things, but since the number is 1, we still do our slope of up 1, or our slope pattern. Up 1, right 1, and up 1, left 1. And we know our absolute value function is a V shape. And then our axis of symmetry is the line that we would draw down the center of the graph, where you could fold the graph in half. So our axis of symmetry is, I'll always start with x equals, because that tells us we have a vertical up and down line. And we use the spot where we cross the x-axis. Right here we cross the x-axis at 2. So we need to do one more example where we see what happens when we have a number in front. So here we have y equals 2 times the absolute value of x. We have to identify all the same things. We have our horizontal shift, vertical shift, whether we flip or not, stretch, shrink, or neither, axis of symmetry, our vertex, and then we will need to be able to figure out our slope pattern as well so that we can graph this completely. So horizontal shift is normally behind the letter x inside the absolute value. Now there's nothing in there, so we have 0 horizontal shift or none. Something, you can either write none or 0, doesn't matter. Same thing with vertical shift. There's no number out there, so we put 0. We look at the number in front to see if it flips or not. That 2 is positive, so we have no flip. But that number 2 is bigger than 1, so when it was bigger than 1, it was a stretch. If it had been smaller than 1, but bigger than 0, so in other words a fraction, it'd be a shrink. And if it had been 1 itself, it would be neither. So horizontal and vertical shift, we didn't go anywhere, so we leave our vertex in the center. So we know our vertex is 0, 0. But then from there we have to do the slope. Normally the slope is 1 over 1, repeated on both sides, up 1 over 1. If we flipped, that would go down 1 over 1. But we did have that 2 out front, so we take our slope and we multiply it by that number out front. We multiply it by 2 to get a new slope we use when graphing. So from this point, we count now up 2 over 1, up to left 1, and our v is going to be stretched closer to the y-axis. That's why it's called a stretch. So now we have our picture. We can draw our axis of symmetry in and write the equation for the axis of symmetry. Always x equals, when we hit the x-axis, we're at 0. So we have the axis of symmetry of x equals 0. So those are all the notes for today, and we'll see if you took the notes in class tomorrow.